Dear students, let us continue our discussion on derivatives. Today we shall solve some more problems on derivatives. The first question is, if y is equal to log x plus root of x square plus a square, then prove that dy by dx is equal to 1 by root of x square plus a square. If y is equal to log of x plus root of x square plus a square, then prove that dy by dx is equal to 1 by root x square plus a square. Okay. So here we have the function y is equal to log x plus root of x square plus a square. Let us differentiate this. Y dash is equal to, it's of the form log x. Derivative of log x is 1 by x. So the derivative of this expression would be 1 by x plus root of x square plus a square into what next? Into the derivative of x plus root x square plus a square. Derivative of x plus root x square plus a square. Derivative of x is 1 plus derivative of root x square plus a square. It is of the form root x. Derivative of root x is 1 by 2 root x. So derivative of root x square plus a square is 1 by, derivative of root x is 1 by 2 root x. So derivative of this is 1 by 2 root of x square plus a square into, now the derivative of x square plus a square. Derivative of x square is 2x plus the derivative of a square. A square is a constant. As we know, the derivative of any constant is 0. So the derivative of a square will be 0. So we get 2x plus 0, which is nothing but 2x. Okay. Now 1 by x plus root of x square plus a square into, here 1 plus, I cancel this 2 gets cancelled. You have x divided by root of x square plus a square. After cancelling that 2, we get x by root x square plus a square. Okay. Now I will take LCM here. This is equal to 1 divided by x plus root of x square plus a square into, take LCM here. LCM is square root of x square plus a square. In the numerator, we get root x square plus a square plus x. Root of x square plus a square plus x. So we should cancel this. X plus root x square plus a square gets cancelled. So we get y dash is equal to 1 by root of x square plus a square. Y dash is nothing but dy by dx, that's equal to 1 by root x square plus a square. Okay. Let's look at the next question now. If y is equal to x plus root of x square plus 1 whole power n, y is equal to x plus root of x square plus 1 whole power n, then prove that x square plus 1 into dy by dx whole square is equal to n square into x. If y is equal to x plus root of x square plus 1 whole power n, then prove that x square plus 1 into dy by dx whole square is equal to n square into y square. Okay. So look at this. We have y is equal to x plus root of x square plus 1 whole power n. Okay. This is of the form y is equal to x power n. Derivative of x power n is n into x power n minus 2. So the derivative of this is y dash is equal to n into x plus root of x square plus 1 to the power n minus 1. Derivative power n is n into x power n minus 1. But in place of x we have x plus root x square plus 1 into, now we have to differentiate this. I am using chain rule here. We have to differentiate this x plus root of x square plus 1. Derivative of x is 1 plus the derivative of root of x square plus 1. Root of x square plus 1, x on the form root x. Derivative of root x is 1 by 2 root x. So the derivative of root of x square plus 1 is 1 by 2 into root of x square plus 1 into the derivative of x square plus 1. Derivative of x square is 2x, derivative of 1 is 0. This 2 gets cancelled. So we have y dash is equal to n into x plus root of x square plus 1 to the power n minus 1 into, after cancelling this 2, we will have 1 plus x by root x square plus 1. I will take the LCM. LCM is root of x square plus 1. This numerator will be root of x square plus 1 plus x. Root of x square plus 1 plus x. Okay, that's equal to, now y dash is equal to n into, here we have root of x square plus 1 plus x. This can also be written as x plus root x square plus 1. Look at this. Here we have x plus root x square plus 1 whole power n minus 1. Here we get another x plus root of x square plus 1. Together it will become x plus root of x square plus 1 whole power n. Here we have whole power n minus 1. Here we have x plus root x square plus 1. So together it will become x plus root of x square plus 1 whole power n divided by square root of x square plus 1. Okay, cross multiply this. Y dash I can also write as x square dy by dx. So we have root of x square plus 1 into dy by dx is equal to x plus, here we have n into x plus root of x square plus 1 whole power n. X plus root of x square plus 1 whole power n, we can replace it by y. In place of x plus root x square plus 1 whole power n, I am writing y. Just observe here, this y dash I wrote it as dy by dx. This root x square plus 1 I brought it to LHS. And in RHS we have n into x plus root x square plus 1 whole power n. Here this x plus root x square plus 1 whole power n, I am writing that as y. Okay. Now let us square this equation. When we square this equation, we get x square plus 1. This root x square plus 1 whole square into x square plus 1 into dy by dx whole square is equal to, on RHS here, it will become n square into y square. Okay? Then let's move to the next question. If y is equal to tan inverse of root of a minus b by a plus b into tan x by 2, tan inverse of root a minus b by a plus b into tan x by 2, then prove that dy by dx is equal to root of a square minus b square divided by 2 into a plus b cos x. 2 into a plus b cos x. See how they have defined. They have taken y is equal to tan inverse root of a minus b by a plus b into tan x by 2. Then we have to show that dy by dx is equal to root a square minus b square divided by 2 into a plus b cos x. Okay, let me consider this. Y is equal to tan inverse of root of a minus b by a plus b into tan x by 2. Okay. This looks like a tan inverse x. This is on the form of tan inverse x. Derivative of tan inverse x is 1 by 1 plus x square, that we know. Okay, so this is of the form of tan inverse x. derivative of tan inverse x is 1 by 1 plus x square. So y dash is equal to 1 by 1 plus x square. Its square, here we have root a minus b by a plus b. Its square will be a minus b by a plus b into square of this, which is tan square x square. Okay, so we have 1 by 1 plus x square into what next? Now I want the derivative of this. Derivative of root a minus b by a plus b into tan x square. So it is a product of a constant and a function. While we differentiate a product of a constant and a function, we retain the constant as it is and we will differentiate that function. So that constant is root of a minus b by a plus b, which I will retain as it is, into, now I will differentiate this function, derivative of tan x by 2. As we know, derivative of tan x is secant square x. So derivative of tan x by 2 is secant square x by 2 into 1 by 2, which is the derivative of x by 2. So this derivative of tan x by 2 is secant square x by 2 into 1 by 2. Okay, that's equal to, I will take LCM here. Before I take LCM, I will write it like this: a minus b by a plus b into tan square x by 2 is there now. I will write that as sin square x by 2 divided by cos square x by 2. So a minus b into sin square x by 2 divided by a plus b into cos square x by 2 into square root of a minus b by a plus b into secant square x by 2 into 1 by 2. This is what we have. Here I will take LCM. Okay, see, the only thing what I did here is I wrote tan square x by 2 as sin square x by 2 divided by cos square. Then just multiply. I will take LCM. LCM would be a plus b into cos square x square. Okay. So y dash is equal to, and after taking this LCM, this a plus b into cos square x by 2 will come up, will come to the numerator. So we will have a plus b into cos square x by 2 divided by, this denominator will become a plus b into cos square x by 2 plus a minus b into cos square x by 2. Sorry, a minus b into sin square x by 2. I have taken LCM here, a plus b into cos square x by 2. That LCM has gone up by a plus b into cos square x by 2. It has gone to the numerator. Then here you have a plus b into cos square x by 2 plus a minus b into sin square x by 2 into root of a minus b by a plus b. Okay. Into secant square x by 2 is there. I will write that as 1 by cos square x by 2 into 1 by 2. Secant square x by 2 I am writing it as 1 by cos square x by 2. Okay. Now I will cancel this cos square x by 2, cos square x by 2. Okay. I am cancelling cos square x by 2. After that, here you have a plus b. I am writing a plus b as root a plus b whole square. A plus b can be written as root of a plus b whole square divided by. Now let us expand this. I will write this as a cos square x by 2 plus b cos square x by 2. After that, plus a sin square x by 2 minus b sin square x by 2. Okay? So you have a cos square x by 2 plus a sin square x by 2, and I can write it as a into cos square x by 2 plus sin square x by 2 plus b into cos square x by 2 minus sin square x by 2. Did you understand this step? See, I will explain again. I am writing it as a into cos square x by 2 plus b into cos square x by 2, and then a into sin square x by 2 minus b into sin square x by 2. After that, I am taking a as a common factor there. So we will have a into cos square x by 2 plus sin square x by 2 plus, similarly, then I am taking b as a common factor from the remaining two terms. We will get b into cos square x by 2 minus sin square x by 2 into So here you have root of a minus b by a plus b, root of a minus b by a plus b into 1 by 2 is there. Okay, that's equal to, here we have root a plus b in the denominator, here the numerator root a plus b whole square is there. So one of those gets cancelled. You will have root of a plus b into root of a minus b is remaining, divided by, here cos square x by 2 plus sin square x by 2, that is 1, a plus a into 1 is a plus b into cos square x by 2 minus sin square x by 2. Cos square x by 2 minus sin square x by 2. It looks like cos square theta minus sin square theta. Cos square theta minus sin square theta is equal to cos 2 theta. So here cos square x by 2 minus sin square x by 2 will give you cos of 2 into x by 2, which means cos x. So a plus b cos x into, so this will give you a plus b cos x into that 2. Okay. So now in the numerator, root a plus b into root a minus b, that will give you root of a square minus b square. Root of a square minus b square divided by a plus b cos x into 2. I can write this as 2 into a plus b cos x. Okay. So we have root of a square minus b square by 2 into a plus b cos x. That's exactly what we want. Okay. Well, let's go to the next question. Next question is, if y is equal to x minus 1 into root of 2x minus x square plus sin inverse of x minus 1 plus sin inverse of x minus 1, then prove that dy by dx is equal to 2 into root of 2x minus x square. So that dy by dx is equal to 2 into root 2x minus x square. Okay. So y is equal to this. We have y is equal to x minus 1 into root of 2x minus x square plus sin inverse of x minus 1. Okay. So y dash is equal to x minus 1 into root 2x minus x square we have. So it is a product of two functions. If it is a product of two functions, then we use product rule of differentiation. X minus 1 into the derivative of root 2x minus x square. Derivative of root x is 1 by 2 root x. So derivative of root of 2x minus x square is 1 by 2 into root of 2x minus x square into what next time? Into the derivative of 2x minus x square. Derivative of 2x minus x square is 2 minus 2x into, okay, derivative of 2x is 2, derivative of x square is 2x plus, say, now what did I do? First function into derivative of the second plus, now second function into derivative of the first. Second function is root of 2x minus x square into the derivative of the first function. First function is x minus 1, the derivative of x minus 1 is 1, so I need to write that. Plus, now the derivative of sin inverse of x minus 1. Derivative of sin inverse x is 1 by root of 1 minus x square. So the derivative of sin inverse of x minus 1 will be 1 by root of 1 minus x square. In place of x I should write x minus 1 whole square into the derivative of x minus 1. Derivative of x minus 1 is 1 itself. 1 minus 0, which is 1. So we don't write. Okay, that's equal to. Here you have, I take 2 as a common factor from this, so that you will have x minus 1 into 2 into 1 minus x divided by 2 into root of 2x minus x square plus root of 2x minus x square plus, if I expand this, let us see what I am going to get. 1 by root of 1 minus of x square minus 2x plus 1. Okay, x minus 1 whole square is x square minus 2x plus 1. On simplification, 1 gets cancelled. You will have minus x square plus 2x. In other words, this will also become root of 2x minus x square. Okay, that's equal to. Here 2 I will cancel. I will take minus as common. So minus of x minus 1 I write. X minus 1 into x minus 1 will become x minus 1 whole square. Minus of x minus 1 whole square divided by root of 2x minus x square plus root of 2x minus x square plus 1 by root of 2x minus x square. Now I take LCM. LCM is root 2x minus x square itself. So y dash is equal to root of 2x minus x square in the denominator. In the numerator, minus of x minus 1 whole square plus here denominator is 1. So when I take LCM, 1 root 2x minus x square is the LCM. So 1 root 2x minus x square into root 2x minus x square, that will give you 2x minus x square. And here plus 1. Okay. Now this on simplification will give us minus x square minus 1 plus 2x plus 2x minus x square plus 1. Okay. X minus 1 whole square is x square minus 2x plus 1. Minus of that will give you minus x square minus 1 plus 2x. This is 2x minus x square plus 1. 1 gets cancelled. Divided by root of 2x minus x square. That's equal to. Now 1 gets cancelled. 2x plus 2x is 4x. Minus x square will give you minus 2x square. Divided by root of 2x minus x square. That's equal to. Take 2 as common. If I take 2 as common, we will have 2 into 2x minus x square divided by root of 2x minus x square. So this 2x minus x square can be written as root 2x minus x square into root 2x minus x square. So one of those root 2x minus x square gets cancelled. So you will have y dash is equal to 2 into root of 2x minus x square. Okay? Next question. If y is equal to secant inverse of root x plus 1 divided by root x minus 1, y is equal to secant inverse of root x plus 1 by root x plus 1 plus sin inverse of root x minus 1 divided by root x plus 1. So is root x minus 1 by root x plus 1. Then find dy by dx. Dy by dx. Okay, this problem looks complicated but very simple. It's a 1 mark question. You just observe here. Here you have secant inverse root of x plus 1 by root x minus 1. I would like to write this in terms of cos inverse. You know one formula. Secant inverse x can be written as cos inverse of 1 by x, which I learned in our other chapter, inverse trigonometric function. Secant inverse x is equal to cos inverse of 1 by x. So secant inverse of root x plus 1 by root x minus 1 can be written as cos inverse of its reciprocal, which is root x minus 1 divided by root x plus 1 plus sin inverse of root x minus 1. Second term you will retain as is divided by root x plus 1. Okay. So now if you look at this, whether anything comes to your mind? Yes, you are right. So this is on the form cos inverse x plus sin inverse x. As you know, cos inverse x plus sin inverse x is equal to pi by 2. Okay, so this expression will be equal to pi by 2. So you have y is equal to pi by 2. Now differentiate this. Y dash is equal to derivative of pi by 2. Pi by 2 is a constant, so its derivative is 0. Y dash is equal to. Next question. If y is equal to x by 2 into root of a square plus x square plus a square by 2 log x plus root of x square plus a square, then prove that y dash is equal to root of x square plus a square. Look at this question. They have given that y is equal to x by 2 into root a square plus x square plus a square by 2 log x plus root of x square plus a square. Then we have to prove that y dash is equal to root of x square plus a square. Okay. So let me take this. Y is equal to x by 2 into root of a square plus x square plus a square by 2 into log x plus root of x square plus a square. Now let us differentiate this. Y dash is equal. So if I differentiate it, it's a product of two functions here. I'll use product rule. First function into derivative of the second plus second function into derivative of the first. So x by 2 into derivative of root a square plus x square is 1 by 2 root a square plus x square, because it's of the form root x. Derivative of root x is 1 by 2 root x. So derivative of root a square plus x square is 1 by 2 root a square plus x square into the derivative of a square plus x square. Derivative of a square is 0, derivative of x square is 2x plus root of a square plus x square into, now the derivative of x by 2. Derivative of x by 2 is 1 by plus. Okay. Now a square by 2 into log of x plus root x square plus a square. Its derivative will be a square by 2 into derivative of log x plus root x square plus a square. A square by 2 is constant, so I will keep it as it is because it is a product of a constant and a function. Constant I will keep it as it is and I will differentiate this function. Derivative of log x is 1 by x, so the derivative of this expression would be 1 by x plus root of x square plus a square into the derivative of x plus root x square plus a square. So the derivative of this is 1 plus 1 by 2 root of x square plus a square into 2x, which we have already seen in our earlier problem. That's equal to. So here I will cancel one of those two, other two will remain. Numerator will be x into x, which is x square by 2 into root of a square plus x square plus here next term is root of a square plus x square by 2 plus next term is a square by 2 into 1 by x plus root of a square plus x square into, here I will take LCM, 2 I will cancel. After that I will take root of x square plus a square as the LCM. Numerator will be root x square plus a square plus x. Okay, so that x plus root x square plus a square gets cancelled. I'll write one more step here. X square divided by 2 into root of a square plus x square plus root of a square plus x square divided by 2 plus, so this x plus root x square plus a square gets cancelled. We will have a square divided by 2 into root of x square plus a square. Okay, now let us simplify this. I will take the LCM as 2 into root a square plus x square. I will continue here. Y dash is equal to, I will take the LCM as 2 into root of x square plus a square. X square plus a square or a square plus x square, both are one and the same. So now if I do that, I am getting x square in the first term because the denominator is same as that of the LCM. And here we have 2 and then the denominator is 2 into root x square plus a square LCM. So I have to multiply this by root a square plus x square. So that will give us a square plus x square plus here also we have this denominator which is the same as LCM. So you just need to add the numerator plus a square. Okay, that is equal to x square plus x square will give you 2x square plus 2a square take 2 as common, you will get 2 into x square plus a square divided by 2 into root of x square plus a square. Okay, 2 gets cancelled. So we have y dash is equal to, so when we cancel that 2, we have x square plus a square divided by root x square plus a square. So that will give you root of x square plus a square. So dy by dx is equal to root x square plus a square. Okay, students, with this I will stop today's class. We will continue in the next. Thank you.